All right, let's dive into something kind of cool today. Compression molding. It's all around us, even if we don't realize it.
Yeah, it's one of those things like hiding plain sight.
Yeah.
The stuff we use every day. Phone chargers, car dashboards, you name it.
I bet most people would be surprised. Like,
Mhm.
whoa, that's how they make that. But okay, before we get to all that, how about the how? What exactly is compression molding?
So picture this. You got this plastic material, could be granules, could be more like putty, and you put just the right amount into a mold, heated mold.
Okay.
And then you bring down this powerful press. Tons of pressure, heat, the whole works.
No, so like a super intense pressure cooker. Instead of an oven, it's this press thing.
Yeah, pretty good way to think about it. And all that heat and pressure, it forces the material to like flow perfectly into the shape of the mold.
Huh. Okay, so it's not just melting the plastic, it's really shaping it with this force, right? But wouldn't that be a problem? Like, it seems slow, and these days everything's got to be fast, right?
You're right, it's definitely not the fastest method out there, but it has its own advantages.
Like what? When would you choose this over, say, injection molding?
Cost is a big one. The molds themselves, especially if you're not making a ton of the same thing, they're way cheaper than injection molding.
Ah, so smaller batches of things. That makes sense. So what else? What other advantages are there?
It's really good for making stuff that needs to be super strong, durable,
Yeah.
like think about car bumpers or those big electrical enclosures.
Okay. But that strength, that precision, it must have some downsides, right?
Well, yeah, it's not perfect. You got to be really careful with the temperature, the pressure, how long it's in the mold. If you mess those up, you get defects.
So kind of high stakes. Like
Yeah,
every little thing has got to be perfect.
exactly. It's all about finding that sweet spot where the material flows perfectly and fills the mold just right.
Yeah.
And speaking of material, there's a whole bunch of options for what plastic you actually use.
Oh, yeah, that's true. We keep saying plastic, but it's not all the same, is it?
No, not at all. There's a whole world of plastic,
Mhm.
different properties, different uses. It's actually pretty fascinating.
I believe it. Where do we even start with all of that?
Okay, so first thing to know, there's two main types, thermosets and thermoplastics.
Two families of plastic. Okay, so what's the difference?
Think of it like this. Thermosets, once you mold them, that's it. They're solid. You can't remelt them or anything.
Mm.
But thermoplastics, it's more like, think of a chocolate bar. You can melt it, let it cool, melt it again, no problem.
Oh, I see. So one's kind of permanent, the other's more reusable.
Exactly. And that's really important when you think about recycling and stuff.
Oh, yeah, that makes sense.
So thermoplastics, you can melt them down and, in theory, make something new. But it's not always that easy.
Why not? I figure just melt it all down, make new stuff, done.
Well, each type of thermoplastic, it's got its own melting point, its own chemical makeup. So some are easier to recycle than others.
Makes sense. Okay, so even within those two families, there's tons of variety.
Yeah, you could spend a lifetime just studying plastics, honestly.
Yeah.
And for each application, you got to choose the right one, just like a chef picks the right ingredients.
Ah, okay, I getcha. So, can we get specific? What are some of these plastic ingredients we're talking about?
Sure. So in the thermoset world, a big one is phenolic resin. Super good for electrical stuff because it doesn't conduct and can take a lot of heat.
Oh, right, so that's why it's in enclosures and stuff. Gotcha. What else?
Melamine resin. That's
Yeah.
what they use for a lot of tableware, countertops, even those whiteboards you see everywhere.
Huh, yeah. Makes sense. It's tough stuff. And thermoplastics. What are some of the big names there?
Polyethylene's a huge one. It's in packaging, bottles, even some pipes,
Ah, so that's what my shampoo bottle's made of.
probably. And then there's polypropylene. That's for like food containers, car parts, even some clothes are made with it.
Wow, it's really everywhere, isn't it? We're surrounded by compression molding. But I gotta ask, what about the future of it? Is it changing or just doing the same old thing?
It's definitely changing. I mean, it's a pretty old process, but people are always finding ways to, make it better.
Oh, cool. So what kind of stuff's happening?
One of the big things is automation, robots and all that, because, we talked about how it can be kind of slow.
Right, right.
But if you can get robots to do some of the work, it speeds things up.
Makes sense. Like bringing the best of both worlds together. Anything else? What other cool stuff is happening?
Well, the materials themselves, people are always inventing new plastics, stronger, lighter, all that.
Oh, wow. So what, like aerospace stuff, medical things?
Yeah, exactly. And then there's the whole sustainability angle.
Oh, right. That's a big one these days.
People want to use recycled plastic or even like plant-based plastics,
Mm.
so it's not all about oil and stuff.
That's awesome. Like making things better A&D, better for the planet.
Exactly. And even the process itself, like how much energy it uses, people are always trying to make it more efficient.
Huh. That's really cool. So it's like compression molding is kind of growing up, right?
Yeah.
Keeping up with the times.
Yeah, I think that's a good way to put it. It's got a bright future.
I like that. It's kind of inspiring, actually. Like, we've been talking about all this technical stuff, but in the end, it's all about making cool things
Mhm.
and making them in a way that makes sense for, the future.
Yeah, definitely. And
Yeah.
maybe next time people see like a plastic thing,
Hmm.
they'll think about all the work that went into it, all the science and stuff.
I hope so. It's amazing when you think about it. Well, I think that about wraps it up for us today. Thanks for taking us on this deep dive into compression molding.
My pleasure. It's been fun.
And to everyone listening, thanks for tuning in. We'll catch you next time for another deep dive.